Welcome back to Apache Spark interview question and answer series. In this lesson, we will learn how to evaluate performance and quality of a Spark application. Evaluating a Spark application is extremely important. Interviewer wants to know whether you understood the correct metrics, tuning parameters, logs, and tools used to measure Spark performance. Let's break this down step by step. What does evaluating Spark application means? Evaluating means checking how well your Spark job performs in terms of execution time, resource efficiency, scalability, stability, job correctness, shuffle and stage performance, memory and CPU usage. In short, evaluation tells you whether your Spark job is optimized and production ready. Tools used to evaluate Spark application. Spark gives multiple monitoring tools. Spark UI, the most important. Event logs, Ganglia, Grafana, Prometheus, CloudWatch, AWS CloudWatch. These are all the monitoring tools used in production. Spark UI shows job stage graphs, shuffle read write, task execution time, skew detection, storage memory usage, executor CPU memory. This is more important place interviewer expect us to refer. Second is event log. Spark logs every event like job start and end, task execution, execution failure, shuffle metrics. This helps us for offline analysis. And the external monitoring tools used in production are Ganglia, Grafana, Prometheus, CloudWatch, which provides us CPU utilization, memory pattern, disk network bottleneck. Key metrics to evaluate a Spark job. Frequently asked this by interviewers. Here are top metrics. First one, execution time. Second is shuffle metrics. Third is task distribution. Fourth is memory utilization. Fifth is parallelism and partitioning. Sixth is cache and persistence. Let's talk about shuffle metrics or shuffle evaluation and execution time. First one, execution time, stage level time, task level time, overall job times. So all these timings will be provided in the Spark UI. Shuffle metrics will read shuffle read size, that is shuffle write size, number of shuffle spill events, shuffle fetch wait time. Shuffle is usually the biggest bottleneck. Let's discuss about task distribution and partition and parallelism evaluation. So, in task distribution, it checks straggler task, which we discussed previously, skewed partition, failed task, executor lost event. For parallelism and partitioning evaluation, it evaluate number of partition, data distribution, stage parallelism. Memory level, we will discuss storage, memory usage, execution memory, GC time, number of out of memory errors, that is errors, and evaluate correct storage level for caching and persistence, whether caching is helping, whether RDD or data frame persist too long. So all these are evaluated. Evaluating Spark application using Scala programmatically. You can capture metrics using Spark Listener. We will write import org.apache.spark.scheduler. Well, listener equal to new listener, override definition on task end, listener task end, unit equal to print task dollar task end dot task info dot task id time colon dollar task end dot task info dot duration. Then spark context dot add spark listener, and we will pass the listener object. You can extract task duration, GC metrics, shuffle metrics, failure reason, but in practice, people rely on Spark UI plus logs. Best practices for evaluating a Spark application. Use Spark UI before anything else. It shows the complete picture of job execution. Check for skew. Uneven task duration equal to skew. Optimize shuffle. Use repartition, broadcast. Avoid wide transformation. Check partition. Too few partitions will lead to slowness. Too many partition will lead to overhead. Monitor garbage collection. Long GC equal to memory mismanagement. Tune executor. Evaluate number of executor. Executor core. Executor memory. Use caching carefully. Cache only reuse data. So these are some of the best practices for evaluating an Spark application. When asked, how do you evaluate a Spark application? You should include use Spark UI, check stages, tasks, shuffling, storage, skew, GC, timeline view, metrics to check execution time, shuffle read write, task duration, fail, stagger task, memory usage, cluster level evaluation, CPU memory usage, executor allocation, event log for offline analysis. This will give you a complete top quality interview answer. That's all for this lecture. You can now evaluate Spark performance using the correct tools, metrics, and best practices.